Okie doke. Thank you all for your attendance. As was previously announced, this is my talk, Code by Mail, a rough and tumble guide to submitting to mailing lists. Without further ado. So, and I should say as a preface that one of the people credited with the invention of electronic mail has expressed that while he had his hand in it, the whole thing was kind of inevitable. And I mean, it's quite possible that it sprang up in multiple places around the same time, but for reasons that will become obvious later, I'm going to focus in particular on the work done at MIT starting in the late 1950s. So you see, this sounds rather obvious at first, but in order for electronic mail to be mail, it has to be written by someone and be addressed to someone else. And in order to be addressed to someone else, there must be someone else, as in another person on the same machine. And you see, that gets really interesting because early electronic computer systems were, in essence, electronic calculators, where instructions or behavior was dictated via switches or plugged wires. And so they required multiple people in order to set them up for a particular task in a timely fashion. Like the weapon ran the ENIAC to perform ballistic trajectory calculations. One more joined later and another wrote the book, so make that 8. But that's not exactly it now, is it? I mean, that's one computer operated by multiple people. So, when do we get to one computer operating for multiple people? Well, the answer is first you have to design machines that can operate for one person, and then you make everyone take turns. The history, at MIT at least, seems to start in 1956 when Douglas T. Ross, who was working at MIT's Lincoln Laboratory, proposed a flexowriter, which is a brand name of electronically controlled typewriter, to be, just a moment here. Douglas T. Ross, who was working in MIT's laboratory, proposed connecting a flexowriter, which is a brand name of electronically controlled typewriter, directly to the Whirlwind 1 computer. A few years later, in 1959, John McCarthy, creator of the Lisp programming language and the guy who coined everyone's favorite term, artificial intelligence, wrote a memo to PM Morse with the same idea, except this time doing more than one flexowriter, and also doing it on the IBM 709 they were supposed to get in the fall of 1960. So they did some experiments, and those would later mature into the Compatible Time Sharing System, or CTS, in the early 1960s. But what is time sharing? Well, you could read the memo, or you could read the section Introduction to Time Sharing from the CTSS Programmer's Manual, but I'll summarize. See, really big computers are expensive to run, so we usually batch all the programs together to ensure the computer always has something to do. Batches were created by taking a program, which you had punched out on cards, one line of code per card, and feeding them into a card reader, which would then convert those cards to an electronic format and write it to tape. Once the batch of programs was written to tape, the tape would be loaded onto the computer, and the computer would run all the programs and print the output. This would take several hours, at least at MIT. The alternative was online interactive development with the computer, i.e. with a typewriter. So that's great for human productivity, but it's harder to justify on bigger machines where it would be an absolute waste of system resources, just sitting there waiting for key presses. So what if the computer spent just a little bit of time talking to one user before moving on to the next? The machine would still be kept busy with work all the time, but all the users would get quick service. This idea of improving productivity by increasing user interaction would form into its own project at MIT, Project Mac, and eventually deliver a second-generation time-sharing system, the Multiplex Information and Computing Service, or Multics. Three parties were involved with Multics at the beginning. MIT, of course, Bell Laboratories, and General Electric. Bell would, of course, pull out of the project in 1969. And then in the early 1970s, two engineers from Bell Labs, Ken Thompson and Dennis Ritchie. And, given the type of conference that I'm at right now, I don't think I need to finish that story for you guys. So getting back to mail for a moment here. Sometime between late 1964 or early 1965, Pat Krisman, Glenda Schroeder, and Louis Pouzin published Programming Staff Note 39 for CTSS with the subject Proposed Minimum System Documentation. What do they mean by documentation? Well, everyone seems to agree that system documentation to the extent of source files, so listing source files and an index of what is in the current system should be available to all users. The note goes on to describe methods for the labeling, storage, and retrieval of documentation and source code for programs, as well as a new proposed command called mail, the mail command. A new command should be written to allow a user to send a private message to another user which may be delivered at the receiver's convenience. This will be useful for the system to notify a user that some or all of his files have been backed up. It will also be useful for users to send authors any criticisms. By the time Neil Voris and Tom Van Vleck were working for the political science department in the spring of 1965, the proposed command had not actually been written. So they decided to write it themselves. Their implementation had some slight differences from the original specification, and that was then documented in section AH.9.05 of the February 1966 version of the CTSS Programmer's Manual. Purpose: to place a file containing a message to another user in his file directory, whether he is logged in or not. So we can learn a few interesting things from this, like the fact that users had private mailboxes that could hold multiple pieces of mail. Each piece of mail had an address line of the form from user problem number, user program number, date, and time. And there were two different mechanisms to mail multiple users at once, either by wildcards of the problem or program numbers, or with a file containing an arbitrary list of space-separated problem program number pairs, with each pair representing a unique user, a mailing list, if you will. So there we have it. That's the history of the mailing list, at least according to MIT. And I could continue with the history lesson, but I expect you all know how email works in the present day. So let's move on to the actual workflow of development using a mailing list. Okay, so step one is to open up your favorite text editor. Don't judge me. And then promptly close it. Because most of the emails you'll be sending to a mailing list aren't written. They're generated from your commits. Now, you can obviously, depending upon the nature of the mailing list, also submit questions or other general inquiries, and we'll cover that in a little bit. But assuming that you're trying to submit code, we need to start with the code. And for the purposes of our examples, we're going to use Git as our source control system, but the fundamental principles should stay the same. So first, obviously, you need to get the project. This can be done in the usual way, or create a fork. But in any case, clone the project. Make some edits using your favorite editor, add some files to your commit, add a commit message, and then commit. And then here comes the magic part. So remember to pull down all new everything. And then you want to rebase your branch on top of the original development branch. And now we're going to run this command. And that returns this. So that's our commit. It's been pulled out of a separate file. And that's what we're going to send as our email. So at this point, it's as easy as, git send email and then the path to file name. But before we do that, we should stop, take a moment, and just take a look at this for a second. Okay, so there's a lot going on here, and tell you what, let's just take a look at the documentation for the command that actually made this whole mess. So, okay, well, it says right here on the tin that git format patch prepares patches for email submission. That's good. That's what we want. And then it talks about messages generated consists of three parts. There's a metadata header. There's a commit log message, patches. Okay, all right. Finally, at the bottom, it says this. The log message and the patch is separated by a line with a 3- line. So, looking back at our message, rather, if we just pull everything out before the 3 dashes, we can see that this is actually the body of our email. It's empty. And that's because our commit log was empty. Aside from the first little bit that got used for our subject line. But seeing as we're basically sending someone our commit, we should probably fill out the commit log, aka the body of the email, with some sort of explanation as to why we are sending this patch in the first place. We should, for instance, probably explain, what file we're patching and also why we're patching it. So let's rewrite our subject line to something more descriptive, like, that. And now in the body of our message, let's describe what the problem is, why it's a problem, what's causing it, and finally our solution. And maybe also some examples of supporting arguments. So, I don't know, maybe something like, or maybe even just that. The important thing is to remember that you're talking to a human being, and depending upon how well they understand the specific code and the coding language involved, you may be able to get away with a less verbose explanation. Okay, so now that we've written a good commit message, we can send our email, but get send email can't send email unless it has our account information, which is stored, of course.
Oh, there it is.
Oh. They said
I gotta-
technology gremlins, they strike again.
I gotta wait for it to like finish crashing.
Is check the mailing list. Back? Everything good?
We're getting there. Okay, we're back.
Okay, I'm continuing now. Okay, so now, of course, if you're subscribed to the mailing list or you've been subscribed for some time, you go ahead and check your inbox. If you want a guaranteed way to filter your mailing list messages, I recommend filtering by the list ID header. Of course, that's not going to help you search for messages that were sent before you joined the mailing list. So for that, you're going to need to go somewhere else. Now, mailing lists aren't like mail trucks. They aren't just a big place where you can store stuff. Mailing lists, by concept, are sort of a decentralized collective agreement. You could achieve a mailing list by virtue of everyone CCing everyone back and forth. In practice, however, we achieve mailing lists by sending our mail to one address, monitored by a service that holds the subscriber list and then retransmits that message to all the subscribers. So the mailing list, in a practical sense, is just every email that was addressed to that service. And these services often archive these messages and make them available in a public way. So lots of projects use GNU Mailman. The archiving thing for GNU Mailman, at least previously, was called Pipermail, which the URLs usually look, something like this. But theoretically, anybody can achieve a mailing list just by being subscribed and then not deleting the messages. This includes other dedicated archive services, which are just subscribe bots that archive all the messages. So kernel.org, for instance, operates an archive service at lore.kernel.org that not only archives all the kernel mailing lists, as you'd expect, but also a bunch of other projects. There's also LKML. Mark is another one. Sometimes whole orgs will have a one-stop shop for all their project archives, like GNU, for instance, or Free Desktop. And I mean, it's pretty straightforward. You click around, you look for a search box, you search for stuff. And then once you find the message, you could quite literally just, copy and then paste all the text into a text file. What's probably more convenient is you want to look for like a link on the page that says like raw or mbox file and then download that. Projects also sometimes have patch or issue tracker sites where you can do exactly the same thing. Stuff like Patchwork. So this is Buildroot's Patchwork. Or Track. This is the one FFmpeg uses, obviously. And in fact, this is often what projects will actually tell you to do. So this is from the Buildroot manual. It says, hey, search for it, look for the link, click, download it. But there is another way to do this. A more fun way. A way that involves the command line. Okay. So buckle up, because this is going to be a bumpy ride, but trust me, it's going to be so worth it. Okay, so lists that use Pipermail with GNU Mailman will have a page of gzip text files by month. So what you need to do is just download all of them and cat them together. So I wrote some JavaScript that does this for me. Don't judge me. It'll do a list like FFmpeg, which has over 250 months at this point of archives in about 3 minutes. Once you have your mbox file, you can just open it up with a command line mail client like Mutt. I recommend enabling threaded mode. But what I would actually recommend is to use this other little email client called Alpine. My favorite. It was originally developed at some university in Washington, I think, or something. I don't know. Maybe you've heard of it. Maybe not. Whatever. I recommend downloading the source for the latest version with the optional patches included and building it. Should only take a minute. Then you want to just plop the mbox file in your local maildir. After that, you want to set up a filter rule in Alpine that just moves all the mailing list messages to that mbox. Job done. That is unless, for some reason, that the archives are messed up. I mean, it happens sometimes. Stuff doesn't get captured properly or things get like weirdly duplicated. Well, do you remember lore.kernel.org? Okay, so lore.kernel.org runs the public inbox mailing list software. That's the name of the software package. And they have an NTP service turned on. So for those of you old enough in the audience to remember Usenet, it's that. So basically, real easy. You want to make a place to store your mail. You want to write a very simple SLRN pull configuration to get all of the messages with no expiration. And then you want to download all the messages. This will probably take a while. For the buildroot mailing list, which is now just over 400,000 messages, this is going to take between 2 and 3 hours. Once it finishes, you want to run it again to get all the messages that came in the last 2 to 3 hours. And now you have a directory that has all the messages in it as numbered discrete text files. See? Whole lot of messages. Now, if you want to use them up, easy peasy. But if you want to use Alpine, we actually got to convert all these messages into an mbox file. So you just cat them all together, right? Wrong. Won't work. Why? There's no from line. From line? Yeah, from line. This line? No. That's the network from line. A colon from line, a 561 spec from colon from line. Got to get a local from line, on disk from line, mbox postmark underscore from line. What's that you say? It's the from space from line. Build a from line. Use grep get a date from the date line because all that they read is the date from the from line. Then you can cat all the mail to the mbox, but wait. Let's mix all the mail, got to go fast with a tool from a set, take a guess, run it home, move across, make a drop, not a box full of news. That's a full stop. I've got almost 500,000 messages in my mailbox right now. And I could show you every single one of them. I could show you every piece of mail that I ever sent to this mailing list. That's not what I want to show you. Instead, I want to leave you with some final thoughts. So for starters, don't top post. You want to reply directly in line. And actually, even better yet, don't quote big walls of text. You want to remove everything except for the bit of the email that you're actually directly responding to. And you want to make sure that the value in your in reply to header is set to the value of the message ID header of the email that you're responding to. Otherwise, it might not become associated with the thread in whatever tracker the project is using. And the email will look like a totally separate thread when in fact it isn't, or it shouldn't be. You want to ensure that the patches you're sending are in plain text. You can check your headers for stuff that looks like content, type, text plain, char set, US ASCII, and content transfer encoding 7-bit. You can actually force this in your git config with that following argument. And then git send email will actually yell at you if you try to send non-ASCII characters in your email. If you send non-ASCII characters in your email may be re-encoded in base 64 somewhere along the route. Ask me how I know this. You can find the talk here with all the various resources, and which is codeberg.org/send-h/code_by_mail. And I can only give you general advice here. I mean, rules and etiquette vary from project to project, but you should check the documentations for a submitting patches section. So, some examples for FFmpeg, buildroot, and of course the Linux kernel. And as a final note on that, I want you to understand that the words you have weight and tone, which is sometimes very, very difficult to communicate through text. This is on top of the fact that you may be communicating to someone in their second language. For a truly excellent talk on intentional tone in emails, I recommend Strategies for Appropriate Social Interaction by Carmen McClelland from OSS North America 2022. And above all else, please be respectful. Because the double-edged sword of mailing lists is this. Mailing lists live forever. 1,000 GUI git issue threads can slide into the ocean. Mail servers can fall over. DNS records can crumble into dust. But as long as those bits are on your hard drive, you are on the mailing list. You are the mailing list. Don't ever forget that. I'd like to thank a bunch of people who helped with this talk. I'd like to thank Linux Fest Northwest for this event, of course, but also the University of Washington, not only for being the original venue of this talk, but also for the software packages Pico, Pine, Alpine, Map Mix, and UW Mail Utils. I'd like to thank the maintainers and everybody else who contributed, and also my dear Aunt Carolyn for suggesting Alpine to me in the first place. I'd like to thank Neil Voris and Tom Van Vleck for email, but I'd also like to thank Tom Van Vleck for the wonderful website, multicians.org, of which my history section is just a crude summation. It's an absolutely valuable resource on CTSS and Multics from someone who helped write it. And last but not least, I'd like to thank my main consultant for this talk, my dad, who turned 2 to the 6th last year, who while attending college not only did his homework on an IBM 360-75 batch system, but also on UCSCB, BDP 1170 running a Unix time-sharing system that anyone, and I mean anyone, regardless of their major, could get an account on. But that's it. That's all. And I'm all out of stuff to say. But if you still have questions, you can send me an email.